the way Intel, AMD, and NVIDIA are famous, no one cares about Mellanox, no one cares about DDN, IO, and all these things. They also want good programmers, good like engineers, and so on. No? Like hardware, storage, interconnect, all these things. So I was thinking, does anyone want to do socket programming and a bit of network security stuff? Actually, ever since that, wait, is there someone who might be interested? How are there so few people interesting? There are some openings in, what is it? It keeps changing its name. That's why I keep confusing. Defense. Wait, what is the name of this new this thing group? Defense DSA or DCA?
Where?
Defense, no, wait. India, the Indian, the military army's cyber command.
Oh, yeah, that one. Yeah. Okay.
DSA, DCA. I keep forgetting the name of this thing. Previously, it used to be the Army Cyber Command National Secretariat. So they are looking for people with some good background in networking and security and a bit of performance stuff. So if anyone is interested in working on what SIGINT, as they call it, then we can go into a bit of networking security. Basically, you'll just keep using Nmap with different options. Huh?
Yeah. Oh, sorry to interrupt you, man. I just wanted to know about basically how do you create communicator groups. So basically, like, so compute per node, you can make it as efficient as possible, right? Yeah. But the problem comes when you're communicating and stuff, and how the network is connected. So those kind of things I've just used rudimentary way. So I was just thinking if you could, I mean, maybe you guys would have used it extensively. So
you mean the network topologies, Dragonfly?
Like how do you create groups, communicator groups, and which is the most efficient one?
In MPA itself?
Yeah.
You don't mean the actual network, hardware network?
No. In MPA itself and the network, if you can sort of relate it. I mean, I'm just asking.
Fine. I see. Communicators we don't use right now because currently it's still under like our. See, communicators will make sense once you have an idea of what is the kind of graph that you have coming out from each node to the neighboring nodes. Correct. And if you want to localize load balancer, then you'll have a nice, like almost every node will have almost the same degree of neighbors around it. And the neighbors will be localized in space also in terms of racks, actual hardware. So your latency time is lower, essentially, a little bit lower. And so, and that also, now how the latency time is lower, that depends also on your network the actual like wire network topology. So there are multiple ways you can do, like you can create these layered network. Is there, I don't know, have you ever seen these kind of graphs called Bethe lattice or wait, there was some very, is Milind here? No, Milind is not here. He was saying that I'm not from physics background, so I don't know about CFD and all these things. So there is something called conformal field theory that is taught in JNC, or Milind picked it up by himself, I don't know. So there, in physics at least, these kind of networks or graphs become very important if you want to do mean field theory and things like that. Like one law of large numbers and things like that.
Did you mention Metis?
Metis is a framework. The thing I'm talking about is the actual, like, the mathematical graph itself, the shape of the graph.
Oh, okay.
So anyway,
I mean, I know nothing about this. So
so basically the thing is, it's such a huge area. Even I have hardly any, like, I've only scratched the surface basically. So if you want to go into this really nicely and be really like go into this in such a way as to be inspiring and motivating, then it will need at least 2 days proper session.
Right.
Okay. So we can keep it as an optional topic, maybe.
Sure. No, I was just putting it in. Yeah, Sure.
Yeah. No, but if you can see, okay, I'll send out a questionnaire today, which will say, yesterday's was what are the crucial topics which are missed out. Today it will be what the optional topics you would want.
Samiti, so this about Metanax thing, IO. So did you? I mean, are you asking us that should we discuss those things, or somebody has asked to discuss?
No, I was asking would you like to know a bit about that? Means will
Oh
it
yeah,
help you in any way?
yeah, sure. I mean, why not? The only thing is, yeah.
No, because yeah, today also Nachiket and Sunil said that office work is hopefully not getting affected for everyone, right?
Okay.
So if I increase this one more day, then I'll be thrown out of the company. Anyway, so let's, without further delay, let's start quickly. Okay.
Maybe next, yeah, sometime, some
Week.
other
Okay,
time, we
gotcha.
can, or weekends.
Weekends, like, though, is a different game altogether. Like calls.
Not full day, but just maybe like 1 hour.
Okay. Okay, well, it'll end up like the Jungle Club only. First two sessions will be very enthusiastic. Third session will be like, weekend, man, let me chill. Okay, fine. So I'll share my screen. We'll get back to where we left. Okay, so we were previously at a stage where we've just concluded creating Git using CMake to build. Is Atif here, by the way? Any chance? Because he wanted to see. Okay, no, he's not here. Okay. So we were using CMake, and what I thought about during this break is that since we are going to quickly cover a few topics on pipelines, Docker, and unit test reports in GitLab itself, after that we'll collaboratively just quickly do a simple project. Every one of us, huh? We'll quickly create a test repo, do these steps from scratch, very simple, no complications and so on, and we'll finish today's, hopefully by 4, today's session on the whole process flow. Okay. Then the other topics which were there for
No, disturbance. Hello.
hello. Yeah, there was a disturbance, is it?
Yes, at least for me, I don't know. For this.
Uh, okay. What I was saying
Yeah,
was that
better now.
Not for me. It was fine.
okay. Fine. So basically, what I was saying, just to summarize, see, we are supposed to finish off Docker, pipeline, stages, artifacts, unit test reports, tags and releases we'll see on the way anyway. We've finished CMake, catch and all those. Coding guidelines and Doxygen strings will not take much time. What I'm thinking is the CMake packaging, no, I don't think it will be required right now for everyone. Because this is a very last stage when the client is almost about to pay you the check, you give it to the client like that. That stage will come later, leave it. Because it's there for some clients. I'm saying for everyone to have that many clients, that stage will come. In due course of time. Okay. So basically right now, few people know this, or if you really want to know this, it's already there in that older tutorial. So you can happily go there and check it out. So I'm saying that just for the sake of time, I'll skip this part, because this is also unnecessarily a bit complicated. This requires you to use CMake for some time, get familiar with it, because this will add in a layer of extra. So basically, it's like, C++, you have used for loop, if else, and classes with member functions. Now this is like polymorphism and template programming and things like that. So one layer of extra complexity. So let's not do this extra layer of complexity right away. Okay, packaging using CMake. So we'll skip that. And this second half of what was supposed to be the second half of today will start afresh tomorrow. Okay, because tomorrow we'll keep it for performance and parallelization and all the really good stuff which we are famous for.
Okay.
So we'll finish off CI/CD pipelines, Docker, and coding guidelines today. So going back to the repo, we were in this branch build using CMake, and if you want to see the state of the code, here's the summary. The CMake file, there's a app, this test, and we were writing how to build make files using CMake and then to make from there. So just before wrapping up this CMake part, and also I think Radhika missed the first session, so this is a summary. So instead of doing that GCC G++ minus OG and command line compilation, we will use CMake to create these kind of commands or scripts on the fly. So a CMake script looks like this. CMake.txt is the name of the script. You so forget about these for now. You add an executable called the name of the executable will be app, and then you tell which source file the app should compile from. In this case, it will be app.cpp. And then you'll have, if you have created a library, you'll link the library using these things. So app will use thermal library, which we will create later on. And then app also includes some include directories or header files, which you include like this. And if you want to create a library instead of executable, you just add a library like this. Let's call it thermal. There are two types of libraries, static and shared. We'll create a static library here. And for compiling, you'll need to include files, and you can rename the library also. So let's not rename. Let's keep it simple.
So static is keyword of CMake file.
Oh, okay. No, so okay. If you go back to the video for today morning, you'll see the I think a lengthy half-an-hour explanation of what is the difference between static and shared. Static and shared library basically is if you go to your Linux file system and go to your root folder, you'll see this lib directory or lib36 and so on. You'll see all of this lib blah 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 .so. In some cases, you'll also see .a files. .so files or the equivalent in Windows, which is called .dlls, are shared libraries, which are basically libraries which ship independent or separate from the actual exe or the executable or the binary. Shared libraries are libraries which, if you link to a executable, that will absorb the shared library content, static library contents into the executable. For shared library, the contents will remain with the library, it won't be absorbed into the executable. So since for shared library, the content of the library and the content of the executable are different, you can swap in, swap out the library versions on the fly, as long as the function signatures remain the same. And then your executable will just point to that library and use the new functions directly without having to recompile the executable again with the new library. Okay. But sometimes for legacy reasons, you might not have the, or this requirement that the library is separate from the executable. Sometimes you might find that the client has to separately install the library themselves and separately install your executable. That becomes a bit complicated. So in that case, people might want to collapse everything into one single executable using a shared library and ship that entire big file to the customer, so that the customer doesn't have to go about installing dependencies and all those kind of things. So these are the two different ways of creating libraries. So here, as an example, we were creating shared static library. Okay. Again, if you go to the video in the morning, you'll see the actual syntax on using G++, how do you create a static and shared library. In CMake, yes, it is just a simple keyword, and you can swap it out with shared like this to create a shared library.
Okay.
And you use this library here to link and create the executable. And as a metadata, you have to give the project that you're making a name. And you need to say what is the minimum version of CMake that you need to use to create this project. So the current version of CMake that I am using is 3.17, I think, or 3.16. Okay. So I am meeting the minimum version requirement. So this is 3.15. 3.15, why? Again, it's there in the video. It's basically it's modern CMake as opposed to 2010 CMake. Okay. The way you do CMake is you call CMake, tell where the script is. So in this case, script is in my kernel folder. You give it a build library where it will build all the intermediate files and make files like this. Then you go into build, and then you call make, because it basically generates a make file. So you can use that make file to create the app and libraries and all those lib is still there. Okay. Or the better syntax or the better way of doing things is you do CMake minus S kernel minus B build. Build is your intermediate build directory. And instead of going into build and doing make, you just say CMake build, whatever your build directory is. So in this case, this one. Like it will internally do make and create all this library, the thermal library and the app and so on. Like this, you can create multiple libraries, multiple apps and so on. And now what we will quickly do is, before we go into the actual CI/CD pipelines, so just to give you an idea of what pipelines is, let me show an actual project which has been using pipelines for quite some time. So there are a lot of pipes and plumbing going on in this. So this is called a pipeline, a GitLab pipeline. Essentially, all this building, unit testing, and documentation generation and all these, you can script out and automate. And the moment you push your code into GitLab, it will trigger all these stages as you wish, depending on which particular functionality you want and so on. So if you go into one particular pipeline, you will see here that I am trying to build a debug version, build a GCC plus Intel MPI version, build a release version, build a legacy version for our clients. And then it will go into testing the CAD part, testing the CAD MPI part, grids part, and so on of the libraries. Huh? And then you can build example files, you can build a user documentation, and then you can build the actual deployable package, like tarball or the zip file, which will contain the exe and the documentation together. And so, and after documentation, you can create those. So the sequence is not very correct right now. Ideally, it should be first build, then test the performance, not just the functional correctness. And then you build the documentation and then you release and so on. But here's, it's okay. Currently, the way I set it up, even if there is a functionally incorrect behavior, it will still deploy. Then I have to go and change the functional correctness and then deploy again. So this is done because when people say, okay, I need this feature right now, I don't care if it is correct or not. I say, okay, fine, you'll have it. It's just not going to be correct. Okay. So anyway, that was a joke. I don't, since it's being recorded for official purposes, I don't make sloppy software like that. Okay. So this is what we'll see, how to automate all these pipeline processes. So we'll go into a thermal example. What we'll do is, we have a README here. So let's just flesh out the README a bit. Say that this solves the Fourier equation for heat conversion into the usage. The typical README that you see written. Usage will be call init function with temperature BC, debulk, and your whatever the temperature grid is, and call update with. There's just a sample README. This is basically what I'm trying to mock a full-blown documentation. So just a few lines here and there. That's all. And update, I think, is CFL, T, temp, and temp. I don't know this. I think these were the arguments. Okay. So this is the functionality, and this is supposed to be your document. Suppose this is your mock document. We'll go into actually building document using Doxygen and things. But for now, let this be the document. So usually you put your documentation in doc folder. So I think it's called docs in our case. It depends. Different people use put as, not put as. So let's just copy the README into docs and say index something, index of the README, or the documentation is there. And what is do you need to make it a complete package? You will need a pipeline. So as we saw previously, that people like to create those separate folders for the intermediate files. Anyway, CMake is going to take care of it inside the build directory itself. But for some reason, if you want to extract out the final app or disk that you built, usually we will package it. So for example, when we did the CMake, the app thing got built inside this build directory, right? So if you look at the build directory, the app is here. So this is the main app that your clients would want to use. So what you do is this is your source code folder. Your client will get something like this. So to client, this is the folder that they will get. See, you will basically copy paste your build app into that. You will most probably hopefully give them a documentation. So this is basically a client who will, or simple client. They don't care about all your library and all your optimization. They'll give me a executable. I'll just do /run. That's it. That is, I don't want any fancy anything software. Then there are like fancy clients. Okay. So let's create a direct packaging for fancy clients. Who will say, or a client. So there will be fancy clients who will say that I will write my own app. You just give me the functionality of a solver in a library format. I will link my app to the library and call the library functions, that's all. Don't dictate how you want my user interface to be and so on, things like that. So for them, you would want to give them the library only, not the app. So you would go into build and get the library. So where's the library? So look thermal.a, there is the library. And the fancy client will get the library, will get another documentation, which is, in this case, not only the docs file, but in code, there is another documentation which we have been talking about, which is include file itself. That is basically the API that your client will use to call the library functions. So you have to give your HPP header files also, the public header files, what you put as public in CMake. So you'll put that inside. So what's the name? Fancy client. So they will get the header file and they'll get the doc also. Although if you give the header file, you should give a documentation also, but technically the header file should be good enough for a smart guy, a person to figure out what the API is. Internally, what is going on, they have no idea because it's compiled in a library, so it has become hidden. And that is one more reason why you compile into libraries, because proprietary code, you cannot expose the source code to clients or anyone else. Then it will be IP backing. So these are the two kinds of formats that you will have in packaging. Okay. So just to see, fancy client will have library and header, and simple client will have the actual end executable and the documentation. Okay, how to run, what are the parameters you're going to give, and so on. So these are the three things. So one is the deployment or production level package that you produce, and this is your source code. So we will see how to use GitLab's full-blown CI/CD, continuous integration, continuous deployment, to do all these things automated. The idea is, as I said in the first yesterday, that you should focus only on changing the logic of the code. All these fancy decorations should be done by GitLab automatically. You shouldn't bother about what is building, what flags to use and all those things. That should, once you write it, it's done. It's there forever. Like it will keep repeating itself every time you make a small code change. Okay, this is the idea. So how do we do it? So for the first thing is, whatever we did, this fancy client and simple client business, we will script it out. First, we'll script it out using a bash script, like locally. Then we'll transfer that to GitLab. So just to quickly summarize the steps till now, if I want to write so package.sh, the first thing that we do is we call CMake to build the finally build the actual executable and libraries and all those. So this is built. Then from the build folder, we will take out the executable. So we'll package for simple client. So we will copy it from the build folder. Okay, we'll first create a folder called simple, thermal simple, thermal mini, and we'll create another package for the fancy client, or fancy, or pro client, called thermal pro. And we will copy paste the build library version thermal.a into thermal pro, and we'll give them in the header file also. So it will be directly from include. And we can give them an example file, but we'll simple. And here you'll give them the app. MD is Markdown. Like that is one more version of fancier version of, or not a fancier, a simpler version of HTML. Essentially, it's a markup markdown markup language. Yeah. So, and usually you don't just give folder, you package it. So usually you will tar it or zip it. So let's zip it for now. So zip thermal mini dot zip thermal, and this one will become. So let's run it, and sorry. You've created your mini thermal current zone. So usually what you also do is you can clean things up a bit. So there is my package. After you're done, you can clean up the temporary directory that you had. Because the moment you forget to git ignore something, it will load up your Git repo. So let's make a clean Git repo. By the way, when we were gone for the break, I included build also in the Git repo. So, and since zip file is again in a sort of weird mashed up binary format, so let us ignore zip files. We shouldn't accidentally commit a zip file. It is only for giving to clients, either via email or via hosting our website. We shouldn't commit the actual package into the repo also. So let's again move all these things. Thermal main, thermal go. This looks fine. Let's add it. No weird binaries are added, so we can happily commit. Since we have been bitten by this multiple times, okay, thank God, I'm in the correct branch now. We can say package script. Add package script. Push. Okay. So now, how do you tell GitLab to automate this, and how do you fetch it back from GitLab? So GitLab allows you to write something called a CI script or a continuous integration script, which is of the form of this .gitlab.ci.yml. So what you do is essentially, if you write a file. So okay, let's close this issue. What was this issue supposed to be? Build using CMake. Okay, we have closed it. So we'll just close it here. Actually, by the way, so Radhika, since you're mentioning that we should do everything from Git command line, the only thing or the reason we kept going into the cyclic problems every time we tried to push to main is that we have, whenever you merge here locally using command line, you will end up merging locally in main, and main you have to then push to remote. But for our purposes, we have blocked any pushes to remote. Okay, so remote, anything that has to be merged into, the reason why we blocked it, if you go back, you'll see that the reason why we blocked direct pushes to main in this remote online version or the GitLab server is because we want our master branch to be the main code. We don't want to, oh, sorry, not this one. What?
Okay, sir.
So we don't want anyone pushing into this master branch without a code review or a merge request. So when you block your main for, like when you block out the, sorry, not there, in repo. When you make your main protected such that you say that no one is allowed to push directly here, then essentially the only way to merge with main is to actually open a merge request here and go through code review. That's like a safety mechanism. That's why we have to use this merge request feature online. If I had unblocked main, then we could have just done that simple merge thing and pushed online, and that whole, that error message that kept coming, that wouldn't have come.
Okay.
So in our case, we cannot do it with GitLab UI because we have to do code review. So, okay, now we pushed branch 6 and right now we have branch 6. Now we have to do a merge request. Again, ideally, if you should be going through a code review, does anyone have to do a code review? mock code review. Otherwise, I have to approve myself. It's like Karthik calling Karthik. Sorry, we have Karthik. See. So okay, reviewer calling reviewer, something like that. So merge. Okay, so this is merged, and hopefully the issue is also closed automatically. Yeah. And then we will go into GitLab CI. So we'll quickly open a issue. Go into pipeline. So create pipeline for build, test, and package. Sure. We'll merge back, so we can create the merge request right away. Let's request branch number 7. Okay. So we'll do a git pull. Let's be very clear and delete our local branch, which we won't be using anymore. Which did not get deleted because we are already in that on that branch. We have to check out to main and then delete. So then the first step, the first step is to actually pull and change to that new thing. Okay. Now, the first step is to write a GitLab means it's hidden, .ci. Now, you can define stages. So let's do a side-by-side comparison of the package.sh we wrote and the GitLab CI that we're going to write. It's going to be very similar. So there is a stage called build. Okay, so you call something build. You can name. So this is basically a name. So you can say build library or something like that. It's like a tag or a name that you give to this stage, and for now we'll call it this build. Okay. Then you just list out the steps that you need, and usually there are like portions which are like environment variables and so on, which are not the exact script steps. So to distinguish what are the extra environment variables and so on versus the actual scripting commands, then you usually say that this is my okay. I'll tell you what. So you define variables like, for example, what do you want to call the build folder? So builder will be called build. Okay, something like this. I think it's colon. Yeah. And then you have the actual script stage. Okay, where you actually give the bash commands. So that will become cmake -s dot -b, and you can reuse your variables which you define, or you can directly put it here. Means directly put build here. I'm just showing you why we need a separate script and a variable section. That is how cmake GitLab likes it. Okay. And then you have and we have already defined builder, so we can just reuse it here. That way you don't have to keep changing your variable names, variable contents multiple times in multiple places and introduce bugs due to redundancies. Okay, so this is the build step. Okay. So let's do this. Let's just do this once and see what happens. I think that would be a good idea. So now you just commit. You have created a GitLab CI. Let's look at the status. That is the only file you have created. You add it, you commit it. Add CI script for build. Okay, let's push. It pushed. Now let's see what is happening in our repo. First thing you'll see is if you go to that branch, there is a cross here, which was not there before actually. It was not there. it says invalid YML. So this YML file is called YAML or something. It's again like HTML, it's YML, and so on. All these are markup languages where you structure data. It's not a programming. There's a whole debate about why HTML is also a programming language. There are things called declarative and imperative programming languages. HTML is a declarative language, a programming language. So yeah, so basically it says that there are errors in my GitLab CI. It says build variable config should be a hash of key value pairs. You can test your this thing with this. So if you look at my GitLab syntax, which I'm very bad at usually, it says this is not correct. And if why it is not correct, I just have to refer to my standard go to GitLab CI, because if you look at variables, oh, no dash, okay. So it is not a list, it's just a collection of things. Basically now if you wanted your source there also, there's a builder and the source there for CMake that you use. So source will be dot in this case. So you can use this. So I'll comment CI script push. Now let's see, did it succeed? Did it fail? It's still, no, okay, that's the old pipeline. It says pending. Something is happening. What is happening? Let's go into pending. It says it's building. So it says test also, we'll come to that. It says building. So let's click on build. See what it is doing. This is where the magic is happening. Essentially, there are a lot of things that GitLab is doing behind the scenes. What it is doing is, it is going to a machine. Okay, in this case, the machine is Amrutahalli. Okay. Okay, it failed. We'll come to why it failed and all, but just see what happened right now. You push the code. Okay, you do nothing else. You just added that file, modified that file, and pushed the code. GitLab took that repo, the current state of the repo, got pinged one of the servers which are attached to it. Like I'll tell you how it is attached. Usually these are called yeah.
You just broke off. Sorry,
oh,
I don't know if it is only.
Sorry, did I break off for everyone? And I'll just tell me where to start from again, like or resume from again.
Just like 30 seconds, half a minute.
Half a minute. Okay, fine. So okay, there is okay, fine. Yeah. I was talking about. Okay, let's go back here. This part was clear when I pushed. That was seen by everyone.
Yes.
Yeah.
For me, it was continuous connection. Actually.
Oh, okay,
yeah,
fine.
yeah.
Okay, so assuming that you have seen that I just did a git push, what happened was, okay, let me just go. What I did was, so we are pushing to branch 7, right? We are not pushing to main. Main doesn't know anything what we're doing right now in branch 7. So let's go to branch 7. If you go to branch 7, you'll see this new symbol has come up here, called pipeline failed for some reason. If you click on this, or suppose you click on this rocket here, which is called CI/CD. If you click on pipelines, you'll see that we have this horrible history of failed pipelines. Okay, you click on the latest pipeline. So this is one pipeline, this is one pipeline, this is one pipeline. There are 3 pipelines. So click on the latest pipeline, and we see that there is a tab here called build. It seems to be like the build stage that we defined here, not the build directory. You can change the name, and you'll see that it's still taking the name that is defined here. So it's called build, and when I click inside, we see this whole whole screen of commands or outputs coming in. So, and in the end, it says that error job failed exit code 187. Okay, so let's forget about the errors now. Let's just try to understand what GitLab is trying to do, why it is failing, or why it would succeed later on, and so on. So when you simply modified the code here and pushed the code, okay, and if you happen to have a GitLab ci.yaml file with a particular syntax like this, basically whatever you had in your package, if you have it in your GitLab ci.yaml, GitLab will basically, once the code is pushed to the server, GitLab will try to detect if there is a YAML file. If there is a YAML file like GitLab ci.yaml, then it will start reading the file. The first steps that we have Okay, and before it starts reading the file even, what it does is it identifies a machine which is free to do some tests or do some tasks on behalf of GitLab. For example, this build, test, and all this run tasks. So for the integrating these free machines, or not free machines per se, like any server which can do all these tasks on behalf of GitLab, I have to install a particular software called a GitLab runner. So there are some machines which we took down or which we integrated for common repurposing last week, which are called which like a Maruthi's machine and the Shashank's machine and all those. We took them and we installed a layer of GitLab runners on them. GitLab runners are like virtual machines. They will create a virtual machine based on a particular OS. In this case, I think the OS would be Alpine. Alpine is a very simple Linux OS, like very lightweight, very thin. It doesn't do much. It's not as fancy as Ubuntu. It's not our CentOS. It's a very simple Linux kernel with some rudimentary stuff on top. The virtual machine that is being run inside GitLab Runner, that will download this OS, create a file system, then download the repository, do a clone of the repository on that file system. So here you can see it is trying to do a fetching getting source from Git repository, this line. Or if you want, I can increase the size a bit, then you can see it better. Okay, running runner, this is the name of the machine by Amrutahalli. So Amrutahalli is basically what was used to be Turbulence till last week. And it's getting the Git repository, fetching it onto this Turbulence machine inside this VM, virtual machine. And then it is starting to execute the steps that we have listed in the script itself. So it tried to execute this CMake -s source dirt builder. It says that when it tried to execute, CMake was not found, which basically means that the OS that it had fetched, it had initialized the VM with, and when it tried to download the repo and do these steps, it realized that I don't even have CMake installed on my Alpine, this OS. So what I have to do is I have to tell it that, okay, you took the bare minimum Linux kernel called Alpine. Now, please, can you do a sudo apt-get install of CMake also, just to initialize, just so that we can use it properly. And since we are at it, when you install an OS afresh, what are the usual installations that you do? One would be Vim, I guess, okay, if you're into Vim. Otherwise, you'll install some other editor. You will install GCC if you're compiling code. You'll install Firefox, usually comes in built nowadays. Install Chrome maybe. So basically, it's like that, the same thing. Just try to remember what all steps you do when you first do a clean install of an OS on your machine. You have to do the same thing here. Okay, I mean, conceptually. We will show that how you can ease that process out, but conceptually, you have to do the same thing because this fresh pulling Docker image Alpine latest is like a pure OS image with no fancy installations on top of it. And where it is running on, that is also a virtual machine. It's like a new machine. Okay, it doesn't have any other software installed on it. You have a new OS, a new machine, and you're trying to directly run this fancy build mechanism using CMake on top of it. Obviously, it will fail. So what we'll do is, in the GitLab CI script itself, we will tell that, okay, before you do this build, let's do some prep stuff. So this is called before script, sorry, the before script part. Or if you want, you can put it inside also. Let's build two stages. We'll call this the prep stage. So here, what we'll do is, okay, we can't build a stage. Let's not do the fancy thing. I'll get screwed. Before I do the build, we'll do a before script. So before script, sorry, it's underscore. We will try to do sudo. What do you do? Sudo apt-get update. That is the first thing you do usually. And then you'll do a sudo apt-get install. What? CMake. And then you don't need GCC because this is a C++ code. So put G++. Okay. So this is what we'll try to run. I can again, okay, let's do this. Okay. Add prep with CMake G++ installations. get pushed. Now let's go to the CI/CD pipelines, this rocket. It says it's running, good. What is it doing? It's going to GitLab runner on Amrutahalli. It's preparing the Docker. Docker is basically the virtual machine. We'll go into Docker a bit more in detail soon. But just imagine like it is creating a fresh machine for you virtually. It again failed. We'll come to white field. Okay. Same steps it tried to do. Now it says sudo apt-get update. It failed. So essentially sudo is not found, first of all. The second thing is we are using Alpine, which doesn't have this
APK
app.
add,
Pardon?
APK add, right? That's the command for Alpine.
Oh yeah, okay. yeah. So the OS that we are using, which is Alpine by default on this machine, that doesn't support this app packet manager. So what we can do is, as mentioned, we can use APK. By the way, have you any of you used Termux on your phones, Android phones or something?
Yes.
Yeah. So are you familiar with this command from there?
No, I just
Alpine from
watched
Alpine
how
also.
to do it.
Okay, fine. So what we'll do is either you change to Alpine commands, but if you're not used to it, then you can simply change the OS itself. Say Ubuntu is free, so tell it to download a simple version of Ubuntu. So you say the image I'm going to use on my GitLab virtual machine for this automation job purpose is going to be Ubuntu. That's it. So it will go online, try to fetch a latest version of Ubuntu like this, or if you want a specific version, you can mention that also. I want specifically 18.04. This is again, this is not like, there's no AI trying to parse your thing. There's the GitLab or Docker syntax, image syntax. These are like well-defined images that you find on Docker website. So if you go to Docker and search for Ubuntu, we'll come to Docker again, like Ubuntu tags, you will find that there are virtual machine images or these installation images, which are called by these different names. So these are the tags that you'll get, 18.04, 20.04, and so on. And you can call them using either Ubuntu latest, or you give Ubuntu : the version name like this. Okay, so we'll go back and use Ubuntu itself. Ubuntu is a bit bulky. Okay, by the way, these were the Docker images of Ubuntu are very, very stripped down images. They're not the bulky 1 GB versions and all those. This will hardly be 100 MB or something. But there's nothing much you can do out of the box with it. You have to install all your fancy software on top of it. That is what we're trying to do here. The second thing is, this again, we'll come into Docker later on when we go. We will remove Docker by default, initializes your virtual machine and your OS in the root mode. So since it's a virtual machine spawned freshly for you only, it doesn't care whether you are the user or the sudo or root or so on, because it knows that once your job is done, this machine is going to be destroyed. Virtual machine is going to be virtually destroyed. Okay, so there's not much use of creating a separate root and separate user and so on. So once you are inside this Docker machine with the Ubuntu image, you're already in root, so you need not use sudo. We'll remove the sudo part here. The second thing is, let's do one quick check. If you do sudo, so mine is Ubuntu here. Okay, we'll do it on the fly here. So I'm just taking you through different pitfalls or very common bugs that we have usually in CI/CD commands. This script is still not bug free, but we'll figure out what the bugs are, where the bugs are. So what we did was use Ubuntu image. So now this is code. Let's go to our repo and here we have it again trying to run. Now it is, as you can see, using Docker executor with image Ubuntu 18.04. It's trying to download Ubuntu right now into the Docker. So it'll take a bit of time, maybe 30 seconds, or given the Wi-Fi speed that we're experiencing today in the office, I am not very optimistic, but let's wait. In the meantime, I'll open up the script. Can you tell me what all other bugs you might encounter? these are a bit non-trivial to find because we are so used to doing apt-get install and all these things on the command line ourselves. What it takes to automate it, sort of you need to basically see the bug once to feel the pinch of it, and then you'll remember forever. It failed. Why did it fail? See, it says, okay, it was able to get the user Docker image and so on, preparing environment and everything. It's getting the Git repository, it cloned the Git repository and so on. It step script or something it was doing. apt-get it did. Now you're doing apt-get and so on. This is very familiar to us, fetched, reading package list. Then you were trying to do apt-get install, CMake. It's reading, it's telling, okay, these are the packages that need to be installed, suggested packages and all these. Then it gives an error saying, do you want to continue? Yes or no? It's expecting us to say yes or no. Okay. But obviously this is running in a very automated way. How will we go in and press Y? Where will we press Y? If I press Y here, nothing will happen. This is a virtual machine running somewhere else. So usually all these things you have to make sure, and almost every command has a way to automate these things. For apt-get install, if you want to by default accept all the changes, you introduce a -Y here. Then it will go through directly without. It's basically it will press Y for you when it comes here. So anything else that you think we are missing? Okay, let's give it a run. Again, comment. Default yes to apt. Git update. This is not Git. Sorry, apt update doesn't usually require yes, but you can put a -Y there. That will anyway update because it doesn't change the state much, so it's not that harmful. So you can apt by default ignores any yes or no thing there. Okay, so we'll again go to the pipelines. It's running. In the meantime, let's look at this metadata, the graphs here. So here there's a needs thing. It says speed up your pipelines with needs relationship. So when you have multiple stages, we'll see how one stage's output can be fed into another stage as a dependency and so on. And then there are jobs. There are like a list of sub jobs in a stage. First of all, there's a difference between a job and a stage, which we'll come to. Right now, we're running just one job, which is basically its own stage. So, and there's something called tests, which says there are no test reports for this pipeline. We will add our unit test reports here. So that nicely after your pipeline goes through, you will get these many physics tests passed, these many coding tests passed, and so on. It will show you the health of the code as it is right now. So as you can see, now it is installing CMake and G++ on the image. So the fresh image of Ubuntu that it downloaded. So this will take a bit of time depending on how big CMake and G++ is. So one thing you can see is that already it has taken 1 minute 24 seconds and it's still not finished even preparing the OS for us or the file system for us. So, and it again failed. So where did it fail, by the way? Okay. So one thing is, this is a good point to mention that you can imagine that for every small mistake, when you're pushing and testing, it will take at least you have to wait for 1 minute 30 seconds for the OS itself to get installed with all the software that you require and stuff like that. So every time you're experimenting, you have to keep waiting 1.5 minutes. Instead, wouldn't it be nice if you had a customized OS for yourself, where you take the base Ubuntu image and you add whatever packages only you need, and you save it somewhere as my Ubuntu 2.0 or something like that. Okay. And that is exactly what Docker images are. And that is where Docker is very useful. It gives you a virtual environment like Conda, or what other virtual environments have you used usually? Conda is the most popular one nowadays. Okay, fine. It gives you a nice independent or enclosed virtual environment. You can use it as a virtual machine on top of your existing OS. For example, if I want to use So let's forget about all this Git and coding and all this stuff once for 5 minutes. We want to, I have Ubuntu installed here. So if you do lsb increase -a, you can see I'm running Ubuntu 20.04. Suppose I want to play around with and feel how CentOS looks like or feels like. Then I have to basically either do a dual booting or I have to uninstall Ubuntu and install CentOS and so on. Instead, what I can do is I can install Docker. If you want to install Docker on your machine, there's a short procedure. It's well documented how to install Docker on Ubuntu or any OS for that matter, and certain Windows also and so on. So you have to do these steps and just these apt-get update and apt-get install. This we'll share later. Let me just show the functionality of Docker for once. So Docker is this command which you say, in which you say Docker run a machine, a virtual machine, give a machine like this is my test machine or something, and give the name of the OS. So in this case, suppose I want to use CentOS 7. And if you want to go into this virtual machine as if you're doing a SSH and run commands inside, then put -i and -t. What are these two things? If you quickly, I forgot, -i is interactive. It will give you a shell to start interacting with the machine directly. -t, I think, is teletype or something. Oh, sorry, Dr. Randall. Yeah, teletype. Okay, I'll leave that for now. It basically attaches your keyboard to the virtual machine. So -i, -t, and CentOS. Ah, okay. Where did my run command go? This is a mistake I did. It should be Docker run and those options. -i, -t. Okay, so you can see I am suddenly inside this root. I am the root user in this weird machine. It's not my machine name, my host name, or my username anymore. It's root at some weird machine. Huh? What is this machine? So let's try to do lsb release. That doesn't work because in CentOS, the version how you check it is cat etc release or CentOS release. Okay, it says I'm in CentOS 7.9. Okay, and if I do ls, it's like the root prompt of something. Is there a home folder? There's a home folder, but there are no users in it. Okay, so basically this is a virtual machine which has been created for me on the fly. It is running CentOS for me. So it's like you're running Ubuntu and inside Ubuntu you're running CentOS. Funnily, you can even install, I think it's a bit tricky, but you can install a Docker inside a Docker also. Okay, to basically do tests on Docker itself. And that is where in the morning I was saying, we'll learn about something like Inception, where you have a dream within a dream within a dream. So it's like a OS within a OS within a OS. And actually we're doing it nowadays. So if you run Docker on top of WSL, that Windows, what's it called? WSL is that Windows
System Linux.
Windows System Linux, yeah. So you're running Docker inside Linux, inside Windows. So something like 3 layers you go into. But doing that is a bit, running Docker inside Docker is a bit tricky because these Docker creators don't want Inception going on.
So how do we copy files from one machine to the virtual one?
Oh, okay, fine, yeah. So this is the machine you have created. So one thing is, if I exit from this machine, will this machine get destroyed? Not necessarily, unless you explicitly tell it to. So let's see how do you, so basically even if you log out, you can come back to this machine again. So you can keep a second OS like this in your machine also. So let's verify that. So I'll go into home. I'm root anyway, I can do whatever I want with this machine. Oh, yeah, I'm already in home. So we'll create a file. So vim abc.csv. It will say vim not found because this is a fresh CentOS installation. CentOS doesn't by default ship with vim. Does it ship with vi? I hope so. It does. So let's write something garbage here and we'll save this abc.txt. And when we exit, we'll again log in back to see whether this file exists or not. Control D, or you can write exit or whatever you want. Now, how do you go back to this machine? So just do Docker minus ps -a. This will basically tell you all the machines, all the virtual machines that you have created on your laptop. So as you can see that I have created quite a few weird machines. By the way, these names were not given by me. If you don't give an explicit name to a Docker virtual machine, it will give a two noun combination. It will auto-generate it from a random list of names and so on. So these are the machines that were created. This was the latest machine. So to log into this latest machine, test machine, you do Docker start, you restart the machine again, test machine. Started it, but you're not being able to log in, right? So that's why you do Docker attach. This is like SSH test machine. Now you're back again. Let's see. We go into home and it's still there. Okay, still there. Huh? Now I can install yum install Vim. And once I've installed it, it will stay there in this OS, in this virtual machine. Okay. So Radhika, you wanted to see how to copy back and forth between
Yes, sir.
So let's quickly install this. See, I could have done -y to escape all these yes, no answers by using a default yes. So okay, now we have Vim installed here. So abc.txt, we can open Vim. Great. So now, suppose we want to move which one? README. README we want to move to this. Just do Docker cp package.this thing, and your machine name is test machine, and wherever you want. So what? Home. That's it. Now if you go back to Docker, Docker start, test machine, Docker SSH, so Docker attach. Ideally, you can't SSH into Docker virtual machines because there is an SSH client. So you have to use Docker attach. You now go into home, you'll see your package.sh there. Suppose you want to copy things from Docker back to your original machine. Same thing, same command, just in reverse. Docker cp, go to test machine. It's like SCP, if you have used that package. Just the tab completion won't work.
So it is similar to HCP in source, destination, and
Yeah.
address. Okay.
Yeah. Okay. Just instead of SCP is Docker space CP.
Okay.
So this is how you copy back and forth. And that is, so this is the Docker virtual machine that GitLab is actually spawning on Amrutali. Or Mohali in this case. By the way, Shashank said, this is your machine that we are using right now for doing these tests. So what we can now do is we saw what a Docker does and looks like and so on. Now the question is, see, we have installed Vim in this CentOS image, right? Now, how do we package this CentOS plus Vim, this combination, this new combination that we have created, and use that for our automated tasks here? Because for this purpose, we will want a combination like Ubuntu plus CMake plus G++. So we need to build a custom OS image like this on top of Ubuntu. The way you do it is you write a simple Docker script or Docker file. So let's, usually people put in a folder called Docker file, or just let's call it Docker file. So this is the standard name that you use for creating a script which will tell how to build a custom OS, Docker file. The first thing is, okay, this I have not done in a while, so I'm a bit rusty with the syntax. Let me just take it up from one of these places. Okay, fine. So the first thing is, what is your base image? You need a base image. Otherwise, you have to write your own Linux kernel on the fly right now, which is, it's not impossible. It's like nasty. Okay, so suppose I want to use Ubuntu 18.04. So from Ubuntu 18.04, what are the steps you want to run to create your new image? So let's say I want to install CMake and G++. So then you will do, so whatever you were doing like a sudo apt-get install and all those, you'll just do that here, except the sudo, because you technically don't need it. You have to do it anyway. So apt-get install, or first apt-get update, that is important. Then you'll do apt-get install Ubuntu. Oh, sorry, not Ubuntu. What am I saying? CMake You can put in a separate line or it's the same line also, this G++ thing. Except that instead, when you're trying to run a command, you preface it with a run. So every command that you're trying to run, you say run in front of it. That's it. This itself is a footprint or signature of how to create your custom OS. If you now want to create your custom OS by running this script, see, we could have done something like this. Remember how we run scripts automatically by doing a hash bin? We could have said Docker here, and we could have made it executable, this Docker file, and we could have just done Docker file here. That would have spawned out a OS by itself, or image of OS by itself. I haven't tried this. I just thought it might work, but usually the command to create a new OS image from this Docker file script is Docker bucket. Okay, sorry, to quickly get back to the syntax. All the syntaxes keep changing over time, that's why I keep getting confused. GitLab gives you handy commands here every now and then. Sorry, this is for logging in. Build an image, how to build an image. It says you can build an image by doing this. Wait. So the idea is Docker build -t. -t is for tag. What do you want to call your image name? Let's call it my CMake Ubuntu. It's very weird. And dot is where the folder in which the Docker file exists. It exists in my folder itself, so I'll just put a dot here. Otherwise, you would have put something like this thing. Okay. Just build it in. Will it go through? Will it fail? Again. So ensure that whenever you're automating stuff, always put -5. So it is, the step 1 was from Ubuntu, it downloaded an Ubuntu image, it's running apt-get on top of it, update, and then it's going to run install CMake G++ inside it. Now it's installing G++ inside that image. It'll take a bit of time because G++ is a bit bulky. Okay, so this is done. Now, suppose I want to locally verify that indeed its Docker is not fooling me. How could it give me a new OS of my own liking, and so on. So you just go to Docker images. It will show you all the images that you have ever generated or created or downloaded from elsewhere and so on. So as you can see, the latest image that we have is my CMake Ubuntu. The tag is latest because you can basically have your own version releases of your own OS. Not your own OS, your own wrapped up OS on top of Ubuntu. So you can make it my CMake Ubuntu version 1.0, version 1.2. Here it is called latest. And surprisingly, its size is only 337 MB, not the usual 800 MB file that you usually get. It was created in 15 seconds ago. So we'll use this image to first create locally. We'll create a Docker using Docker virtual machine running this custom OS. Okay. So what we do is we'll do Docker. We set run -i interactive -t for attaching the keyboard, and then we will name it as my compile machine. Okay, and we'll use the OS that we created. So my CMake Ubuntu. And if you are using a version, we could have used version 1.8 or something. Here we're using latest. Nice. So if you go in, you'll see that you're indeed using Ubuntu. So there is nothing called cat CentOS and so on. Instead, for Ubuntu, you have a LSP release. Ubuntu 18.04. Nice. And do we have G++ and CMake installed? Let's see. Do we have CMake? Wait, 3.10. Or remember we put a minimum required of 3.15 there, so our code will fail if we use this OS. Just as a heads up. And G++, which version is it? 9.5. Great. So as you know, Ubuntu doesn't come inbuilt with CMake or G++, otherwise this job wouldn't have failed. Now you can see that we have a custom OS built using these combinations. Now the question is, how do you make GitLab use this? Oh, by the way, let's just quickly remove this image and get Ubuntu 20.04 running, because that has CMake 3.15 or 16, whatever I'm running. Otherwise, if you want, you can keep a very old OS and locally like build the software package yourself from source, like by writing all the steps here, step by step. How to run, okay, fine. We'll go into the details of how Docker actually works and so on later optionally, because that's another deep thing. Deep means you can go very deep into it, how layer by layer it starts hashing different, basically it's like layered file systems. When it downloaded Ubuntu, it had a base layer. On top of it, it applied the layer, it's like commits basically. It applied the layer of this run apt get -y update. Whatever was changed if you take now the bitwise representation of the entire file system of the OS plus this update step, it will hash it and create a unique hash. And then it will see if any other OS or any other virtual machine in your local machine can reuse that hash. That is how it saves so much space. Basically, it won't create entirely separate images for different combinations of apt-get install, apt-get update that you're making. Whatever layers it can use, it will reuse. But the only thing is, it can only reuse layers which are continuous. So for example, if I have one custom image which does Ubuntu apt install, update, install CMake G++, and then if I do one more OS, so let me just call it Dockerfile 2, this invalid, it should always be called Dockerfile, and that's why you should always put, if you want to create multiple versions of your OS in the same repo, then just make a directory called Dockerfiles. And inside that, you make different versions of your OS. So basically, this will be my CMake Ubuntu. And you can move your Docker file from outside into this. And if you wanted to create another OS, suppose it's called my CMake, what is that you usually, oh, Vim. CMake Ubuntu. And here, you're just trying to modify, this Docker file as, instead of, let's break it down a bit. Let's just run it separately, then it'll be easier to show what I mean. This was, suppose, a Vim thing that we wanted to create, and this is the, let's see, where am I? My CMake Ubuntu has actually both of them. Let's rename it properly, otherwise half the fun dies in the rename. Most of the information will be in the rename itself. So okay, this is my Ubuntu CMake G++. Okay. We'll rename this to that, my Ubuntu CMake to this, and we'll rename this one CMake Vim 2. Technically like show what are the steps we are doing. Ubuntu CMake Vim. Now we'll create Docker scripts for each of these. So G++, Docker file for G++ version, and this is the Docker file for the Vim version. Okay. Let's do a comparison. So here we have Ubuntu, layer. So this layer is the same. So essentially, if I now on top of this, like I've already created this right-hand side version of the OS. So if I am going to create this left side OS image once more, it will not download Ubuntu again. it will see that Ubuntu was already present previously from some other previous OS build, so it will reuse that effectively. Only when you're transferring it to some other computer where there is no previous build, it will attach it to, like, absorb it in itself and then ship it separately. As long as your computer has already a Docker image of Ubuntu or some other OS that can be reused, it will reuse it. That's why you can save a lot of space by using Docker. It reuses a lot of components from other Docker images that are present locally on your system. What else can it use? This step of update. So when you run update, it would have installed some files or modified some files. Here also you're running apt-get update. The signature, the script signatures of both these sentences are the same. So Docker will assume that these give the same output. If the input is the same, the output is the same. It is a deterministic system. That is the philosophy Docker works by. So even if this OS was built, suppose in 2015 using Docker, and I'm trying to build this now, obviously the apt-get -y update will give very different results. The repositories will be updated to much newer versions and so on. But Docker believes that the syntax is the same, the output should be the same. So if I run, if this was run in 2015 and I already had a local version layer of apt-get update on top of Ubuntu stored in my system, and now I'm trying to build this OS with Ubuntu and apt-get update, it will not run apt-get update anymore. It will just reuse this layer itself, this combination of these two layers, basically. This layer and this layer. So usually if you want to always update your OS image, then usually what people do is they'll put some other, like, just break the signature a bit. They'll put something like pipe it to something, null2 or dev null or something. Or they will put a slash or a comment or something like that. Or true. And weird things they will do. This is a weird thing of Docker, but it is how it is. If anyone knows of any other better way, please let me know, because I don't know. A better way of remaking Docker layers. As of 2018, that is the last time I actually did some background check on Docker, or background study on Docker. So in this case, the first three layers from this will be reused by this. And then this layer is different from this layer. So install Vim will be done fresh. If I try to build this OS right now, this left side one, it will actually reuse only the first two layers and build a fresh install CMake or install a fresh CMake and Vim, because the signature of this line and what line was there previously, what we built it with, is different. So it knows that this it knows, this it doesn't know. It's not that smart that it will be able to understand that install CMake is basically a part of install CMake G++. Okay. So it's going to do install CMake afresh here. So this is how Docker works. This is basically to show you that if it adds stuff incrementally, only if the previous stuff was reusable in a consecutive manner. If there is any, consecutive manner in the sense that if I suppose go into this mode, so it basically takes the lowest common set of steps as reusable, and then it cannot reuse anything that breaks the sequence. Because if you insert a new layer in between two previous layers, it still makes the layers above sort of new, and so on. Just to prove the point, if I do something like this, and then do something like this, it is going to install gedit in both the cases, because you have a different layer sitting in between. Okay. So it is effectively like Vim downwards and G++ downwards to Docker, everything is different now, because one line became different in the middle. So this is how Docker works. So let's not spend too much time more here. Let's delete gedit. So now how you want to break up your signatures, install signatures, it is a complete art. What minimal set of functionalities do you think will be used often and often? You can put those in the same line. Remaining, you can put in different lines and so on. It depends. It's a personal choice. There's nothing like there's no rule about it as such. Okay. What am I doing? Okay. So we will not use Vim for the automated task because we are anyway not going to use the user interface. So we'll delete the Vim part from here, or you can keep it, it's not an issue. Or we'll delete it. Skip the entry. Otherwise it's a little confusing. We can give a better name to this my Ubuntu CMake. We usually, actually there is no particular, we call it builder. I call it builder always because after Bob the builder or something. Okay. So this is how you build your required. Oh, by the way, yeah, the thing which we were wanting to change is it has to be 20.04. I hear 21.04 is really bad. People are like dissing it left and right. So let's not use that. We'll create a Docker, new Docker image out of that custom thing. So we'll have Docker build -t tag is builder is the name of the image. And where is the file? The file is inside Docker files. So we'll call it my builder. Thermal builder. Ah, that's a good name. As you can see, it took just maybe a fraction of a second to do this first step because I already have Ubuntu 20.04 used somewhere else in some other image. So it just used that part. But apt get -y update, I don't think the signature is present anywhere in other images. That's why it started doing the refresh. Okay. So it's installing CMake and G++. Now we will see how to reuse it inside GitLab. So now that we have the image on the machine, somehow you have to tell GitLab, look, I have an image on my machine. I really want you to use this on your GitLab runners, on all the Amritahalli, Rachanahalli, wherever you are trying to do my build tasks and run tasks. So what you need to do, okay, it has to install G++ now. By the way, is this clear? As long as it's building, it's finished building. So we probably is everything clear just 2 minutes later again. So to push the image onto Git, you can follow almost the same syntax that you use for repositories like git pull and git push, except do it as docker pull, docker push. Okay. So GitLab will tell you the syntax. So any repository you go to, let's go to the thermal repository itself. Why should we go to core? This is our repository. You will see a thing called packages and registries. Conan infrastructure, leave it. We don't need it right now. Container registry is the registry you want to go to. This basically keeps copies of the custom images which are related to this project. Okay. So you can see that it says there are no container images for this project per se. What you can do instead is you can do Docker login to our GitLab website. It's like logging into GitLab itself. So you will do Docker login. Most probably for some of you, this step is going to fail because you don't have the required HTTPS certificate that is recognized by GitLab or by this Docker services. If that is so, I'll give you the certificate, just install it using 2 simple steps. I'll show it to you. Let me just show it just for posterity's sake. There is a file called ca.crt, okay, which I'll give to you, like I'll share it with you. It's a bit, don't share it everywhere. Like I'll upload it somewhere. Let me upload it temporarily somewhere. That way you can access it. I have it with me. How do I put it somewhere else? We will use packages website directly. You can use that. So the question is, where do I have my ca.crt? That's the question. I'll have it in etc shared. No, certificates. Oh god, it's not here. I'll get it from somewhere. Wait, just give me 1 minute. By the way, are people still here? I am like, complete silence.
Yeah.
Okay. That I dropped out. Thanks.
Yeah.
Okay. So we just said it's in user share. So let's find out if it is there or not. Linux comes with so many files, it gets very confusing where things are. Where? Oh, in this. Okay, okay. Oh, there are multiple CSS certificates, is it? Ah, nice, nice. Thanks. So I'll upload it to my desk. And then I'll push it to as you might have seen in the email, you will be able to host your own files and packages internally. Just put it in, clean it out, your username. I don't have that right now, and plus I'm using it for official purposes, so I'm going to put it inside the official SS Labs hosting space. Listen, and I'll put it here. So you can get it. God, sorry. PKGS. Okay. So basically anything after PKGS, whatever the path is, let me press copy. After PKGS, whatever the path is, you can just go to your browser and go to pkgs.sanketlabs.com and paste that path. Is everyone able to see this file, ca.crt at this URL?
Yeah.
Yeah. Okay. If anyone is not, just let me know, because that means I'll tell you a very nice trick of using VPN in a different way so that it gets automatically recognized. Everyone is able to see, is it? Is it? Oh, very nice. Everyone's configured the VPN very nicely. Okay. So, okay. So you can download that. If you open it, I don't think there will be anything useful per se. You'll see something like this, but if you open it in Vim, you'll see a lot of hash signatures like this. Please don't share it with anyone because it's a very sensitive thing. If you share this with other people, they might even break our website also and put random stuff there. So if you want to do it, then come to me, ping me separately. I'll tell you how to, but don't share it with anyone. Okay, so ca.crt. What you do with this is you essentially put it in. Ravi, do you remember the steps? I keep forgetting the steps. There are two steps. One is copy it to some etc, share something. Where is it? It will be somewhere in systems only, I think. Ah, yes, it will be in systems. It's an open repo, so anyone can see it. Fresh install of GitLab run machines. Yeah, here. Install CS certificate. Yeah. So can you just do these two steps? Sudo cpcsert wherever your local copy of that file is, to user local share CS certificates, and then do a sudo update CS certificates. You can do it later also, just ensure that you do it before you try to do Docker login. Otherwise, you'll get a lot of these X509 certificate unauthorized errors and things like that. And you'll go into a path which will make you hate Git, hate Docker, hate GitLab, hate everything about life. Okay. So don't go down that dark alley. Install your CS certificates and be happy. Okay, fine. So if people are done, or you can see the GitLab, it's issue number 87. Note number 4 days ago. Okay, install the CS certificate. Okay. So you can do that. And we'll go back here now. After all these things, if my own system fails to recognize Docker login, that will be the saddest thing ever. But okay, I'm hoping my system is configured. I haven't used Docker login for a long time because once I built all my necessary custom images, I have not built any Docker images ever since. Yeah, so what we do is we have built a local version of our image. Oh, that got over, is it? Remember. So let's quickly check. You can go to Docker images. There is something called a thermal builder, latest version, very nice. It's built seven minutes ago. Size is 378 MB. So the step we are going to do next, we'll be uploading 378 MB. So please do it at your own risk. If you have a data connection or network connection, depends on that. Let's do it someday, but not right away if you want. So the first thing is, as GitLab will tell you from the container registry page, is that you do a Docker login onto sanketralabs.com code. So it'll throw a warning, something that is, it says login succeeded. So I am actually inside sanketralab.com, this GitLab's Docker registry space. So now that I'm inside, any local image that I have, I can push onto the online Docker registry that is there inside GitLab. So what you do is you build your image. In this case, see, we have built our image, custom image, using something called Docker build -t. We use thermal builder, right? And Docker file, which was this one, Docker files. Yeah, okay. So we use this. Now, GitLab says if you do this, it will just remain on your laptop. We won't recognize that. If you want GitLab to recognize that you want the image to be used along with your GitLab repo or stored in GitLab, then use this command. So let's see the command. Instead of Docker build an actual arbitrary name, what you do is you give it a name, which is the URL of your GitLab repo, wherever you want to store the Docker image in. So this is the name of the GitLab or URL of the GitLab repo that we are using right now. So this is it. And then with a colon, you can give a name. So in this case, we can call it thermal builder. And dot is basically the file where the Docker file is. So it's our Docker file /builder, right? So we'll have to build the image like this. In this case, if I click, it will finish off immediately. Why? Because we have already built thermal builder locally. If we want to build the image again, just with a new name, it will reuse all the components from the previous image. As you can see, done, finished. Essentially, this is like retagging. Whatever image it had, it just renamed it or copied and gave a new name to it and so on. Okay. So, okay, it has been tagged now. So we have an image like this. So if you go to Docker images, you'll see that you actually have a big name wala image. So the name of the image or repository is this, and the tag is thermal builder here. Previously, the name was thermal builder, the repository was thermal builder, or tag was latest. So basically, names are called repositories, and the versions are called tags here. So, used about. And then if you want to push it to GitLab, you use like git push, you use Docker push. Docker push. So Docker push, the name of the image. This thing, thermal builder. During network connection, this will take a bit of time. As you can see, these are the hash functions on the hash signatures of each layer on the site, and it is pushing each of those layers online now. So basically, this image is made out of 1, 2, 3, 4, 5, 6, 7 layers. The biggest layer would be the Ubuntu image itself, and on top of that, the apt-get install layers. Okay, so we have it. Now let's go online and refresh the page and see if something has happened. Yes, we have one image here. There's one tag, and it is called thermal builder. Okay. Once you've pushed an image, try not to use this button because GitLab is really bad at implementing the Docker container cleanup thing. If you remove this, it will stay, it will not get removed. If you want to remove Docker images from your GitLab registry for any particular purpose, just let me know. Like just ping me once before you do anything. Because if you click on any delete image and so on, given the current versions, actually I don't know if they've corrected in the current versions of Docker. 2 versions ago, at least, it would be a hell to clean up the image actually. Because the image will stay and then the links will be broken and everything will start failing. So you can keep pushing as many images as you want. If you want to delete an image, just ping me once. So what we'll do now is we have pushed a version of our Docker image online. Now we will just reuse that Docker image instead of the fresh Ubuntu image in our CI/CD script. So back to CI/CD. What is the name of that image? You can just go to that same thing and check what it is called. So if you look here, it will be called this manifest digest. This small copy button here that you see, that basically lets you copy the path of the image itself. What you refer it to by. This is the path, which is the same path you push to essentially. Okay, it's a bit big, but yeah, depending on if your path is big, your Docker image name will be big. So now that we are here, we don't have to do Docker update all these things. No need for backward script. Yes, this should work. Should it not? What was the last error we got? Can we just quickly solve the latest error and then where's CAC? Yeah. Failed. Once your series of red marks turn into green, that is when you get to say failure is success only if you learn from it, or whatever that code was that people selected majorly. So it says CMake error because the directory build does not exist. This is a very funny error. Okay. I think I understand why that might be the case. Let's try this once. This is just for, we'll see how to use variables. I'm just trying something for now. Let's get at least one commit with a green tick in the pipeline. So you can see use custom image. What happened? Yeah. By the way, if you just log in and you can check yourself also, like just to make sure I'm not making all this up. This repo is public. Oh, I think it's public, but you won't be able to see it. Wait. Because the visibility of the CI/CD pipelines is might not be public. Oh, public pipelines. Yeah, you can see the pipelines. Fine. So let's go back to pipelines. Let's see the pipelines. It passed. Great. Finally, our build stage passed. Job succeeded. You have blah, blah, blah. Everything is done and so on. So now what to do? It passed. That's it. There is nothing to download nowhere, means I'm not seeing any download button anywhere. So what you need to do is, see, we were planning to build the code and then package it such that we can download a fancy client.zip and a, what is the other one? Simple client.zip, right? So we'll quickly try to modify or update our YAML file that after building, don't just exit and leave us whole like with nothing. Allow us to package for a clients. So package for fancy client is one tag. Here, what we'll do is we will reuse the output of this step, of this build step, in this package for fancy client step. So suppose we had the files built by this step with us, then what would we do? We would just create a fancy client directory. And then we would copy we have it already, why am I writing it separately again? Oh, kernel mini and all those things. Okay, fine. So we'll just copy paste this. Huh? So we made the directory, we copied from app, then we zipped it. I am hoping, does Ubuntu have zip by default? I don't think so. We'll have to update that Docker file also with add zip. Or do you have tar? I think they will have tar. They might have tar. Is that fine? Like just come pre-installed. Okay, what is, we'll install zip. It's okay. Install zip on Ubuntu. Libzip or what is it? Zip. Okay, fine. We'll do an apt zip later on. Just remember, we do a push this thing and you delete. There's no need to delete thermal mini because anyway you're not going to. Okay, now the one thing is that when you write stages like this, so okay, this is called a task or a job. It's called a job. Okay. This is one job. This is one job. The job name is this first line of each section. Script is the task it's going to do in the job. And you can have multiple jobs running simultaneously in a particular stage. So for example, this is a packaging job for a fancy client. Similarly, you can have a packaging job for a simple client. So you can, we copied the, this is the problem. Copied the simple thing in the fancy one and the fancy thing in the simple. So we'll call this as fancy and mini client. Okay, pro and mini client. Okay. So these are two jobs which seem to have the same kind of concept, which is packaging. So what we'll do is we'll group them in a single stage called script, in the sense that jobs can run simultaneously in a stage because they don't have any dependency on each other. Like this packaging job depends on the output of the build step, but it doesn't depend on the pro client's packaging step, right? So these two jobs can run in parallel, and these two can run only after build has happened. So how do you bring in this dependency? You go to a job. First, you say which stage it belongs to. So this belongs to the stage called packaging stage or something. You give your own name, basically. Whatever name you give, you will just have to mention it above here, called stages. Just list down the stages, which order you want the stages in. So I first want build, and then I want package. And since I've written a build stage, this is the name of the job. This is not the name of the stage. So here also I put a stage. The build and the stage name can be, the job name and the stage name can be same, but if you really want to keep it separate, you can call it build generic or simple or something, as in it's not optimized. Similarly, you can have an optimized build. So this is like plain build and debug build or optimized build and things like this. So let's do that. Let's have two different builds. Okay, let's have a single build right now. We'll come into build processes later. So you have stage. Now, how do you tell the dependency? You say that this particular job needs job, give the job name, which is plain build. And do you need the artifacts from the job? Yes, I will need. Artifacts are basically the end products or output files that are created from this job, or basically whatever files are there present after this stage is over, which will include the files it came with, and also on top the new files which were generated by the script actions in this stage. Okay, so just let me quickly check what the syntax of the build system is, because I can keep forgetting all these things. By the way, this core repo is public to everyone, so if you also want to quickly check any reference syntax and all, you can always use it. Stages, correct? We list stages like this. We have an image. Forget the dot thing. Oh God, I'm using fancy things here. Okay, fine. Let's go down a bit. Artifacts, yes. And needs job build release artifacts is true. Okay, fine. So this indentation and dashes are the ones which I keep confusing. Artifacts. So what this says is you need the artifacts or the files that are created from the plain build job. Okay. If you just wanted it just a dependency, you really don't care about the files per se, you can put artifacts as false. So here we will need the files, so this is true. And here also we'll need the files, so this is true. So we'll just copy paste this here. Okay. And for the plain build part, you will have to say, please save your artifacts, because dependency jobs will use them. Okay. Otherwise, it will delete its artifacts and kill itself. Why is that required? Because each job will run separately, independently, unless you explicitly make a connection between them. This is like MPI, not OpenMP. It doesn't share the same virtual machine. Each job will run on a on a fresh virtual machine with a fresh copy of your image. So only if you explicitly transfer some files and data between these virtual machines, then only there will be some dependency. Otherwise, it will just almost run independently and so on. So here it's like 1 MPI process, 2 MPI process, 3 MPI process. Now you have to make those MPI communication connections or like this dependency charts right now. Okay. So how do you do that? You say artifacts, you give the artifact name. This will be the name of the package, and the GitLab will compress that package into a zip file and add a .zip after this name. Okay. So it will be name.zip, and give the paths of so what all folders you want to be include in the package. And expire in is basically the time limit for the package to stay available on your repository or on GitLab. Because if everyone starts pushing, like keeping all the packages alive for forever, then slowly we'll run out of space again. Okay, so we keep our packages alive for only 2 hours till we have downloaded it. Or if you're doing a real release and so on, then you can keep it forever, at least as a reference version. But that is also not needed, because whenever you want, you would be able to rerun the same Git pipeline. If the code has, since GitLab creates a snapshot of the code, it will run the same code the same way. Unless your hardware or your instruction set architecture itself has changed, you will most probably get the same code output also. So we'll do artifacts. Yes. And what is the name? So name we would give is, this is the build state. So there's nothing. Actually, do we need to give a name for this? We don't, right? We just need packages because we don't really care about the name per se. Okay, fine, we'll give a name. We'll say these are the build output. And then we'll do paths. In this paths, we will just include everything. So star. This is the simplest way of doing things. A very bad way, it will copy everything from here. Ideally, what you would have wanted is, you would have wanted to copy only build/app. And what else was needed? libthermal and .hpp. Anyway, for now, we'll just do all. This dependencies and all we'll see later. Except this is basically, those are optimizations, how few files you can transfer instead of the whole bulk thing. Expire in, yes, please. That big a file, we'll keep it at 2 hours or 30 minutes, let's say. You can use it. GitLab understands M for minute, min, R, HR, all those things. Okay. By the way, if you have any questions about these, you can ask. But if you want a reference for later on, GitLab CI pages, for example, you can search for CI/CD pipelines, and you will get entire reference of how to do pipelines and variables, jobs. The main CI/CD examples. So there are a lot of examples here you can go through. For example, if you want to go through something with, mostly these are for web app kind of things, not really for, okay, there is a C++. Oh, there's a template, okay. Okay. So here you can see it's artifacts, paths, and the binary. It's trying to load. So we can do that as well. And if you don't give the name explicitly, it will give, I think, the job's name .zip as the artifact or something. Let's do that with the name, you know. And here we will also want to download the artifacts created by this package stage, because if you don't explicitly mention artifacts here, it will create this zip file and then forget it. Okay, means it delete it, or the virtual machine will get killed by itself. So you won't be able to download it. So by the way, instead of zipping it yourself, that is why we don't install zip in things. Because GitLab is so nice, it will automatically zip all the files for you. So you don't need to install zip separately. So it's a good thing. There's one more reason why you should use GitLab instead of writing your own packaging scripts. So here also you say, I want artifacts. Artifacts are basically downloadable at each stage. Give it a name. The name of this will be mini for mini client. And the path will be, let's pack everything. Let's see what all is there. Huh? Everything will get packed and packaged. And expire in, we'll say 30 minutes. And this is to Pro client. So this is the status of our pipeline now, or script now. We'll try to see what pipeline it generates. So I'm hoping everyone is with me till here. Because now we are really going to see a lot of UI fanciness from GitLab. Package build files. Okay. So let's go to the pipelines. Let's hope it doesn't give a cross again. Happened. It says your GitLab does not have valid YAML syntax. Why? You can, where is it failing? So it says you can use it, CI lint to check your configuration. Can I just reduce the size a bit? Yeah. It says post your contents of your GitLab, so we'll do that. Once GitLab files get, this YAML files get big, it becomes very difficult to figure out what the problem might be. This is your own YAML debugger. Okay. It says syntax incorrect. Did not find explicit at line 15, column 9. Line 15. Oh, sorry. So it says that you can't do a start. You just put the name of the file or the folder that you want. So we'll put a // okay, which means this folder, or dot essentially. Star is invalid. So fine, we'll put a dot. Is this fine? Validate. Yes, it goes through. It shows you even what are the jobs that you have. There are 3 jobs, and there are these parameters and so on. And you can do a simulate also. Simulate the pipeline. Yeah. Validate. And so on. Syntax is correct and so on. Clear. Wait, is it actually simulating? No, okay, thank God. Yeah, why did it try to do it twice? That is interesting. 11. Oh, it tried to merge also. That's sad. Okay, fine. So we will just change our stuff there. Update our YAML with dots. And come back to git commit. Same. CI environment script. Push. Now it should work, hopefully. Yeah, okay. This is going through. As you can see now, stage-wise, there's a build stage and a package stage. There's one job in the build stage, and there are 2 jobs in the package stage. Ideally, if you look at the job dependencies, you'll see that the 2 jobs depend on package. They don't depend on each other. So these 2 can run simultaneously. This will run serially. Like first this will run, then these 2 can run simultaneously. So if we go down, this is running serially. This is still paused. Let's see what is happening here. It's still trying to download this image. Its size is, oh God, there's no files to upload. There are no matching files. This is sad. Okay, so we'll give the file names explicitly this time. Apparently dot doesn't work. I'm surprised. I thought dot will work. maybe GitLab said no more dot business, no more all files business. Everyone is misusing GitLab that way. You can misuse Docker in multiple ways because it gives you a free virtual machine and OS access like this. There are fancy ways you can misuse it. So we will need the build folder. And technically we don't need anything else. No, we will need this include folder also and the docs also actually incorporated in this. Yeah, that should be it. And now we should have terminal as the output. And also have terminal pro. So we have docs, we have build, we have include. I think we should be good with this. Comment. Required folders as artifacts. Okay, so now again we got the pipeline. Pending. Why is it pending? Are there not enough runners? How many runners do we have right now? Let's see. Currently, I think I'm using Amrutali and Rajanali also, but I'll take those out because if people want to run jobs there, they can do. Okay, we have enough runners. We'll go back to it's running in Rajanali. Is downloading the image for the first time on this machine because last time when it failed, I think that new image got downloaded to Amrutahalli. Isn't it? Yeah. So this is the first time Rachanahalli is going to get a taste of Thermal Builder OS. Ah, passed. Awesome. As you can see, you have job artifacts appearing here now. If you want to browse it, you can see it has build, docs include. Build is here with all the build files, thermal.a and app included. You have your docs files also in the package and the include files in the package as well. If you want, you can download this intermediate doc and it will output as build_output. That is the name you had given or I had given. And now if you go back to these stages, you look at the job dependencies, you have a needs diagram also, which says this is the stage and this pipe fits into these, like this pipes into this and that and so on. You have the jobs, all are passed. That's not them. Show dependencies. Okay, this is the first pipeline we have created successfully. Now if you go into here, we can see these are all there. The job artifacts are also there. If you browse here, we can see there's a thermal mini waiting for us with the app and index. The index is actually the index that we wrote, hopefully. It could not be rendered. It's a job, okay. So we'll download it. If you want to download it, you can download it from there as zip file, or you can just go to the pipeline. It's accessible from different places. So you can go here to the pipeline view itself and say, download which artifact you want. Package for pro client, you want package for build, you can package for mini. We'll download the pro for once. Or we'll download the mini for once because it's an executable. What we'll do is, suppose now I am the client, I am the mini client. So I'll go to the folder and I will try to delete these because this is not what we need. Suppose I'm a mini client, I'm not going to use terminal as long as I can, but I have to actually. What should I do? Oh, sorry. I was supposed to extract it, not open it. Extract here. Suppose Sangeeta has given me this thing, so I'll go inside. I'll see, there's readme. The readme says init update, which I have no idea about what it means. I see an app, I see an executable. I will innocently run it. And ran. You build an application in God knows in what machine in Amrutahalli, and it ran on your machine. This is, I think, a first example of how the whole software industry works since 1960s, where you build software in certain machine, ship it, and then when you go, for example, if you want to, since we're talking about all these things, our IT support person, he recommended that everyone use 40 client dot the app here instead of using the embedded VPN controller that we use. And if you go here, you will see, for example, where's 40 client? Yeah, product download, and you can then download for different versions. So you can download, for example, for VPN, you can download for Linux, RPM, deb, macOS, and so on. So the thing that you have created is essentially what is contained in either an RPM package or a deb package. If you just add a few more metadata, this is what will become an RPM or deb package. Or you can just zip this file itself and give it to clients, they'll be more than happy. Okay. So this is how the entire process works, from a simple C code to testing, building, packaging, deploying to clients. Okay. So what do we do now? We will quickly, what is time? We're over time. Do you have 10 minutes? Should I quickly run automated testing script with the catch test that we wrote and see test logs in the pipeline if it's failing or running, and then we'll be done for today. I think apart from code styles, that is it about the whole process. That if you are able to follow this process on a daily basis for your codes, as I said, Ambani family will send you mithai after mithai packets. Okay. So actually, it's not going to be like that. It's like you. Pardon?
Do you get those packets every day?
Okay, no, everyday packets. Everyday is like a healthcare problem. Like mithai every day is like that is anti-employee act. Diabetes, what all you'll get, I don't know. Oh, once a month maybe, yeah. So what we'll quickly do is like we did this build-in package stage, we'll quickly make a test stage also. Okay, nothing. You have to just go back to your CMake list. You have to say like you built your library and executable. You have to just build your test executable also. So what I'll do is add a test executable. This is called app. This is called test all. If I run this, all the tests will go through, or will be run, not go through, will be run. So all tests will require the terminal library. And we'll just quickly put in the source files directly here. Oh, sorry, these are the tests, not source. So we did test init.cpp, we'll test update.cpp. And you have a public header, and as we discussed before, you can put the unexposed or internal header which we are using, catch, as private. So tests vendor is your file. Inside that is the catch2.hpp. That's it. Oh, sorry, one more small thing. This link, this variable name. So this is your create tests. Create app. Create like. So this is your CMake, and similarly, you'll just include your test stage. So you'll build and then test. Usually people build the app and library separately in different stages. That's a bit fancy. No need to be fancy right now. It's already past 4. So what we'll do is we'll do a plain test, all tests, running all or unit tests. So we will go label this as test, or you can, if you have multiple tests and you want to run multiple independent tests or unrelated tests in parallel, you can make multiple jobs with the same test stage. Like we did 2 different jobs in the package stage, but right now we'll do it single step. So we will, we'll need our previous job for that. So we will put the needs condition here. The sequence matters, but it's good to mentally put the sequence. Sorry, why am I deleting this? This is true. Script will be required to run /. So the test will usually be in, okay, let's do a quick local build because I also keep forgetting where the test will end up getting built. So let's remove this build. This is our clean folder right now. And we will do a cmake minus s dot minus b build. Good. Let's see. Build. By the way, if you want to quickly parallelize your build, if there are multiple build steps, you can do a parallel 4. It will use 4 threads to build parallelly. If there is scope of building parallelly, it's just a thing. Like for some reason, target app. Now the tests are getting built and it's taking so much time because that catch.hpp is a monster. Yeah. Okay, test got built. So if we do a tree now, we will try to figure out where the tests is. Test is here. All tests is here in build directly. Okay, nice. So we'll do build all tests. Beautiful, all tests passed. And if we do minus minus success also, it will show me all the succeeded tests as well in detail. So should we intentionally fail a test so that you can see how the report looks like with a failed test? I'll show you. Okay, we have enough failed tests in the other repos. We'll try to quickly pass this test now. So this is where it gets built. So in your GitLab.ci, the way you run your test is, you come here, you run build all tests, just the way you did manually. And then in the artifacts, you don't need any artifacts per se from here. It will show up on the screen itself. That is fine. Instead, so this will not show up on the screen. So it will it will show up on the screen as in this screen, this sort of virtual terminal that you have here. Okay, the log from the terminal. It will show up as pass, but that is not how. That is also not good enough. GitLab is really fancy. It will let you list down exactly how many tests passed in a table-wise fashion. If you want to see how fancy it is, then go again to the code repo. There are not too many tests there, but it proves the point. I think you won't be able to see the code repo. Maybe I'll show it to you here itself. The tests in the code repo. So it looks like this. Okay, like duration of the tests and how many failed, how many total, how many skipped, and so on. And if you go into each of the tests, it will show you exactly how each of them passed and view details and so on. Okay. If there are no failures, it will just show tick, tick, tick. If there are any failed tests, it's very hard to find a failed test in the repos because I only write unit tests which only pass. So no, we will have examples of that. That is actually the main example, that you make a test fail. There are examples where you have your tests failing. So let's go here. Tests, yes, failed. Still 0. Okay, sad. We'll see. There will be some examples somewhere. We'll figure out. Basically, it will show you the precise location of the line numbers, the snapshot from the lines where the test condition failed. So you'll be able to exactly know which test failed. So we will run the test, and then to create this kind of a nice statistics output, you just have to output the build, this all tests, not into the terminal, but into a XML file. And the way you do that is, again, please let me just copy paste from my repo because that is a syntax I keep forgetting every time. Yeah. First this. So as we were saying yesterday, if you look at, sorry, what did I do? If you look at the build all tests, this thing, it will output to the screen. Then if you use help, it will list different options. Out of one of the options, there are different reporter types. So list reporters will give you the different reporter types, and you can use one of those reporter types by passing it in the reporter name. So if you do list reporter types, list reporters, we'll show you there's compact, console, JUnit, XML. We are by default, I think, using console or compact, one of those two. So if we just change the reporter type to compact, shows like this. If we change the reporter type to, well, let's do compact and success, maybe that will look nice. Oh, very nice. So it looks like this. It shows exactly what the tests are, what passed, how many passed. Decent enough for a console output. If you use console, it will look like this, a bit bigger. If you use something called JUnit, it will create an XML file like this, with which can be read by other nice structured data parsers. Or if you use directly XML, it will create a plain XML, not JUnit. So JUnit is also an XML syntax, but XML is just a bit larger, and so on. So GitLab understands this format of test results called the JUnit format. Okay, so we will throw it out in JUnit format, and the way we do it is we'll write. We'll run the test case. Here I'm trying to run MPI test, so just ignore that. We'll report as JUnit and out. The output file will store in a file called report.xml, and we'll pass that report file to JUnit reports. So it's just boilerplate code syntax, just copy paste and put it. There's nothing fancy conceptual going on here, unless you work for GitLab itself. Then you have to maintain this code, so you need to know what is going on behind the scenes. So. And I did the mistake of doing Control-Shift-C to copy from a HTML page. Cardinal mistake. Okay. So I have this. You're essentially outputting to report.xml. Then as artifacts, you're passing the build paths. This will fail definitely because, yeah, indent. No indent. That's surprising. Let me not break the syntax. We'll play around with that indent. This looks a bit weird. So report.xml is just here itself. So we will take it from here. And in the report, we will pass this report.xml. 5 and 30 minutes. That's it. So we are done, I think, almost. Status. That's the only file change. CI. Run tests and report. JUnit format. Push. Sure, it will fail somewhere. Let's see where. Because whenever you're doing something nice, it has to invariably fail once. Okay, at least we have the stage here. As you can see, it has nicely layered itself, saying that my This is very interesting. So see, now you can actually play around. It's your choice how you want to build the dependencies. Do you want to package the code only after the unit tests have passed, which makes sense if it's a very high, it's a very sensitive client. They will not accept any package that doesn't pass unit tests. So then you can essentially, let's do that actually. Now GitLab.ci. Only if we pass the unit test stage or test job, then only we will accept packaging, or then only we will start packaging. Artifacts is false. We don't need the artifacts for the packaging stage per se, unless your client wants to see your test reports. That's a typical client to deal with. So here, so again quickly. So only after test. Start another. Oh, nice, it passed. So as you can see, the dependency was this, and here, why are there no test reports? Finally. Let's zoom out a bit. As you can see, our unit tests have passed. If you go to unit tests, you'll see our unit test case 1, update case 1, and unit test case 2 passed. If you've forgotten yesterday or whenever we were writing those tests as test init was, if I initialize with BC temperature to be 80 and bulk to be 10, it should come like this. So those have passed, and so on. Few details. If it has passed, it will just show you the name and the timing. That's all. If it fails, it will show you the snippet of the portion of the code where it actually failed, and so on. 100% success rate. This is like brilliant stuff. Okay. And for the new pipeline, which we quickly did, something really weird is going on here. Okay. So, but why did it say my what is artifacts? Is there any other mistake? They make a spelling mistake here. No, that's fine. Please pass. Actually, I'm surprised it's failing twice. There's some weird thing that is going on. Maybe there's some new GitLab behavior. If it fails, they'll make it count twice as failure. Oh, one is the branch itself, one is the merge itself, which is a bit weird. I see. There's some new GitLab behavior. This I have to go into. This is anyway. Let it pass. Then we'll see the job dependencies. Now it is nicely dependent like this, which is ideal. And here you can see the time taken is 33 seconds instead of the long times that was taking previously when each machine was downloading its first copy of the thermal printer image. Now that Amrutahalli and Rachanhalli has at least once downloaded the copy of that big OS image, it will keep reusing it. It will not download it again unless there is an actual change in the image hash and all those things. That way it's very fast. Okay. Unit tests are running. Succeeded, done, very good. Why is it update? Yeah, packaging is running. Pravagada. So, oh, beautiful. This also ran very fast. Okay, so now we have a very nice pipeline ready and set for delivery. Okay, so what is this? Oh, something weird happened. Anyway, so now that we have nicely tied up our code with a pipeline, we can see which branch we are on. We can merge it, do a code review first, then merge it. So there's nothing to change here. So we will do a merge. Approve. It says it's still in a draft stage. Once the code review is done, you can do mark as ready and then merge. There's a whole step of 2-day code review because there are 12 commits, but if the code review goes through, you merge. You can review the full report also, what all passed, what all failed, and so on from the merge request. So this is the place where all the big meetings and discussions happen in your code review. This report is the evidence. The changes are your defendants, and yeah, this is the whole process. Okay. And I think now it will merge into main. That's why main is also running a version of the test just to see if it can, if main, the current state of main, which is this merged state, if that is also passing. Okay. So as you can see now, we have quite a few metadata on our folder itself. This doc includes SRC, and till now we used to use only include SRC. Now we know about tests. We know about documentation. We'll cover a bit tomorrow maybe. Docker files, Docker containers. Package is not required because we're anyway using GitLab, CI, and CMake. So if this is clear, from tomorrow onwards, can we start doing some hands-on coding? Because I'm pretty sure everyone will ace finish off the parallelization and optimization stuff very quickly. That is like simple stuff. Well, simple stuff in the sense that it's more understandable. It's more hands-on and things like that. But this process stuff, it requires a bit of getting used to. It should be very difficult initially. Why do I have to do these unit tests and why do I have to write that CI/CD and so on? But once you start actually coding libraries which are 10,000, 50,000 to 1 million lines long, these are your friends who are going to come to save you. Otherwise, you'll tear your hair and go bonkers. Okay. So this is the methodology, and I am hoping this has passed. Please put a tick here. Beautiful. We are done for today, I think. There's more than enough. So branches, we are only one branch. There are no open merge requests. This is a repo, which is like the ideal of repo kind. Okay. Okay. Yeah. So any questions? There were no questions in between. So I'm guessing either it's pretty simple or I failed explaining somewhere, and then everyone got bored.
I think we need to practice this.
Yeah. Okay. So any questions? Any questions? Any stage that you would like to be covered a bit more in the next classes? Don't worry. If you ask a question, I'm not going to do it today. I know everyone is tired. So any specific questions or steps that you want to revisit?
I think we'll start to use this process. On the way, we'll have some questions. I think definitely where we fail, then we'll get back to you.
Okay.
I think.
Yeah, you gave actually a pretty thorough introduction. Actually, introduction or let's say procedure. It was pretty thorough. Thanks.
Okay. So yeah, so basically apart from this, okay, there are multiple now advanced levels of these and so on, but those are not required by some. If you are able to follow this, then we can as I kept saying, parent company will be so happy. They'll invite you to Bombay office only. Oh, by the way, we might have to shift our offices because the rate which our vacant seats are being filled up. Like there were what 10 vacant seats remaining, no? Near the conference hall and so on. Yeah, today Kishore was showing me a printout of the vacant sheets versus the occupied seats. And he was saying by this winter, I think we have to move out to a bigger place.
Oh, is it?
I don't know. Yeah.
Hopefully in Manithon, I don't, not Reliance facility in Whitefield, right?
No,
Oh,
but
why?
why hopefully Mangalore? I hope it's somewhere towards some better part of Bangalore.
Oh, you want in Bangalore only? Achha, okay, fine.
So you are coming to Pune?
No, not Pune. I was thinking Himachal someplace nice.
move to Cochin.
Yeah,
Karthik, do you want
Cochin
to-
is peace. Cochin is peace. We'll go to that Kumaraga by the backwaters.
Nice. Yeah.
I think the discussion has again started. When we were in JNC, that this discussion was huge. When are we shifting? Where are we shifting? And this is again started.
Yeah.
Any idea, Samadip, where they might shift? Like,
No, I think as long as this COVID thing is on, Nachiket is more worried about whether we should keep the office rented or we should give it up.
okay.
Because it's just waste of this thing.
True, yeah.
No one is coming. So, yeah. We are experts at parallel distributed computing. No, we'll distribute offices. 4 people in small rented houses here, wherever you want.
Smaller Aero, one smaller health group.
Yeah, do you remember there was a building, IBM building right opposite to our building?
IBM building, yeah.
Yeah, so they have left it seems. So we can get that.
That whole building is vacant right now.
Yeah.
Oh my god, that's a perfect place for having a haunted, this thing. Some scared people away.
Yeah, actually.
That's a
Yeah,
big
top
building.
floor can be our office, and all the below floors we will stay. Apartments.
Yeah.
Yeah. Okay, fine. So then it's almost 4:30. We'll close here. Any questions? We'll send out a feedback form again for today, and this time it won't be. It will be tasks. Okay. We'll see what tasks, but this time.
Hey, somebody, are you recording these sessions?
Ravi, it depends on how much storage he has left. Okay.
Because this current
push
session,
to-
I want to put it on video and do it myself. That way.
Okay. Yeah.
Ravi,
So,
Yeah,
Ravi?
actually.
Are you planning to edit this into modules, and are you will you post the videos entirely, like whole videos?
See, last time what we had done is the 2.5, 3.5 hour long continuous videos. See, again, if you have to slice, then we have to use those fancy software like so on that. And basically, what we do is we put timestamps for each topic. We put timestamps on YouTube, so you can get the table of contents, and wherever you click on topic, it will take you to that timestamp. Is that okay?
Yeah, nice.
So in the previous videos also the timestamps are there. Actually, I estimated the time that would be taken by each module looking at the previous timings. But the previous timings I was doing in such a hurry, still it became 5 hour long video. Now that 5 hour has become, at least we have been talking for now, what, 10 hours? Yeah, and maybe next time we do a bootcamp it will become 20 hours. So we'll see. Okay, fine. Then we'll upload it today itself and we'll send the feedback form. The feedback form will contain questions from specific timestamps in the video. Okay, I'll figure out what are the timestamps to put questions from. Okay, fine. See you then.
Okay, bye.